Hello, this is section 5.2 ellipsis. So we talk about circle. Now we're going to talk about ellipsis in 5.2. So 5.2, number one, deriving the standard form of the equation of ellipse and then graphing ellipsis. And number three is finding equation of the ellipses. So ellipsis equations, the definition of the ellipse is a set of the all points in a plane, the sum of the which of the distance to fixed point is we call the foci is a constant, which is stays the same. So we'll be studying ellipses elongated either horizontally and vertically. So considering the two fixed points mentioned in this definition, we can picture a loose piece of string tied onto the two texts that are placed either side by side or up and down from each other. The two texts will represent the foci if we put a pencil inside of the string, keeping the string tight as we circumvent two foci, we will draw an ellipse. Because the length of the string does not change, the sum of the distance from the two texts will remain the same, and definition of the ellipse is satisfied. An ellipse will have numerous components of the discussion. So, which is the very important thing is, okay, for the ellipse there's a center which represent H and K as like a circle, and then important thing is actually the A here. So A is the important thing because A determines the major axis and the B determines the minor axis. Okay, so less center is in here, so just the origin. Okay, so that's the center, which is H and K, and then this time A square is come with an X on the top, which means we got the horizontal axis. Okay, so which means you will find the X units from the center, and then you need to go to the exactly same thing, same units to the left. So there's a negative A here. But in here, B is, but another important thing in the ellipsis, A is actually the greater than B, which is a positive, okay? So that's a very important order. So B is on the vertical axis, which is right here. So this is a B, and then there's a B is the same distance from the center too. And then if you put them together, which is you get this nice ellipse shapes, which is the oval shapes. So oval shapes we call the ellipse, okay? And this is over. All right, for the next one, actually the center is the same. Sorry, passing it up. Center also H and K, okay? But this time is the A square is come with a Y this time. So which means from the, let's say center is the origin here. And then you go A units and then down to A units. And then you go B units on the right and you go negative B units on the left. And then if you put them together, if you connect them together, and then you, hold that second, it's not right, sorry. It should be the nice, okay, hold that. So you can connect them nicely, make the ellipse that we can find, okay? Yeah, that's it. It's the same thing to A is greater than B. Okay, but there's a foci. Actually, the foci is right here. So foci is in the less than the actually the A. So see here and then sorry about that. Oops, sorry about that. I think I should use the, even though it's the smallest, okay. All right, let me try this here. Okay, so this is a negative C, which is a C represent the foci, okay? And then this is the positive C. So your positive C here, and then negative C here, okay? So actually the A and C, which is the foci and the vertex goes together. So A we call the vertex. And then there's another vertex. Together we have two vertices. And then this is a focus. And that's another focus. And then together we call the foci, okay? All right, let's go to the next page. The list of the component involved with the ellipse will include the following. Foci, two fixed points placed side by side or up and down from each other. Center, the midpoint of the line connecting the two foci, also the midpoint of the vertices and the endpoints of the minor axis. Number 3, major axis the longer of the two axes, which is same as a 2A. And minor axis is the shorter of the two axes, same as 2B. And the vertices, the endpoints of the major axis, and then the co-vertices, the endpoints of the minor axis. So vertices determined by A square, and then the co-vertices determined by B square. So consulting the textbook for the derivation of the standard equation of the ellipse as x minus a squared over a squared plus y minus k squared over b squared equal to 1 with center h and k. So a is the distance left or right from the center to either of the vertices or co-vertices, and b is the distance up and down from the center of the either vertices or co-vertices, and c is the distance along with the major x to the foci where this is a very important formula to get, okay? So foci is coming from the c, but in order to get a c is c squared always equal to a squared minus b squared. So h minus k squared over b squared plus y minus k over a squared equal to b1 is, what is the width, sorry. And the center is the same, and then the a is the distance up and down from the center of to the either of the vertices or co-vertices. B equal to distance right and left from the center to either the vertices or the co-vertices. And then C is the distance along the major axis to foci where the same formula we have, okay? All right, next page, please. So graph each of the following ellipse by finding the center and co-vertices and the foci. So in here, center is h and k, but there's no change from the x squared and y squared, so it's a 0, 0. And then you need to find a squared, but a squared is always bigger than b squared, so I need to say 25 is a squared. So 25 is right here, right? Which means you can solve for a is a plus minus 5, because you need to put the square to both sides to get that out, right? And then b squared is going to be the 16, and then square to both sides with a plus minus, and then b becomes plus minus 4. So I think we're ready for graphing for the ellipse already, okay? Okay, so from the center, 0, 0. Then you go to the, so this time a squared come with a y, so you need to go up to 5 to get vertices, okay? So from the center, you got 1, 2, 3, 4, right here, okay? So this is the vertex 1, and then down from the origin, 5 units, 1, 2, 3, 4, 5, and this is a vertex 2. And then go right to get the co-vertices, which is, I want to call the endpoint 1, to the left 4, 1, 2, 3, 4, and another endpoint 2 for the ellipse, okay? So I'm going to connect them nicely with the 4 points, so making as ellipse. Oh, it shouldn't be a circle though, okay? Yeah, I think it's very close to be a circle. So, okay, so this is better. All right, now we have to find this. So we got the center, okay? And then we have co-vertices. It's co-vertices from the endpoints, okay? So I want to say 1, 1, 2. So I got to say 4, 0. And then negative 4, 0. And then we also need to find the foci, but foci's formula is c squared equal to a squared minus b squared. So a squared is 25 minus 16, which is 9. Okay, and then the c is actually the plus minus 3. So C, the foci along with the vertices, okay? So from the center, you go 1, 2, 3 up to get the foci 1. And then you got 1, 2, 3 units to get the foci 2. So for the foci, it's going to be the 0 and 3. And then 0 and -3. Okay, so we find anything, everything what they need, okay? All right, now next one, the center is -2 and 1. And then a square, I have to say 9 this time, which is 9 equal to plus minus 3 because 9 is bigger than 4. And b squared equal to 4, which is a b is plus minus 2. Okay, so from the -2, 1 as center, right there, center. And then this time as 9 come with an x, so horizontally you got the vertices, okay? So you go 1, 2, 3 to the right. From the center, 1, 2, 3 to the left, okay? So, and then you go up to 2 and then down to right here, okay? All right, and then you can just connect them to get the nice ellipse. All right, yep. Okay, so now the center, we found it. And then we have to find the covertices. Covertices is on the vertical axis side. So I can say that as this one, covertices. Okay, so this is -2 and 3. And this is -2 and -1. And then for the foci, which is I have to use the formula. So c squared equal to a squared minus b squared. Which is a squared is 9 minus 4, which is 5. So c equal to plus minus radical 5. So radical 5 is about, you have to use a calculator to figure it out, okay? So square root of 5 is about 2.2. So from the center, you go to the 2.2 on the right, about here, which is a foci 1, and 1, 2, 3 right here. And this is a foci 2. All right? So you can just, as a foci, as a point, you can see it, a foci here is a better way is use actually the center. So center is a -2, but you go right or left, right? So plus minus radical 5, and then it stays a 1 all the time. Okay, that's the point that I plotted it. All right, SC. 2x squared plus 3y squared minus 8x plus 6y minus 1 equal to 0. So how do you know this is not a circle? There's a big point, okay? So because of 2 and 3. So x squared, y squared come with the different coefficients, and it's going to be the ellipse, okay? And not a circle. All right, so in order to find the center, that we have to work it out, okay? All right, so how do you work it out? So first of all, I have to put the 2x squared minus 8x together, 3y squared plus 6y together, plus 1 both sides, okay? And then I need to make a grouping, and then factor 2's out, so x squared minus 4x. And then 3 factor it out, 2y equal to 1. Now I'm going to do with 2 times x squared minus 4x, and then I'm adding the number. And 3 times y squared plus 2y plus adding the number. And then I have to adding the number on other side too as a 2 times and then 3 times. So -4 divided by 2 is a -2. -2 squared is a 4. And 2 divided by 2 is a 1. 1 squared is 1. So I need to multiply 2 by 4 and then 3 by 1. So I have a 2 times x minus 2 squared plus 3 times y plus 1 squared equal to, that's 9 and 12, right? So it's going to be a 12. And then I'm going to divide by 12 both sides. That's a standard form because I need to make it equal to 1. So I got x minus 2 squared over 6 because reducible. And then I got 3y plus, oh, so cancel. What am I doing? Y plus 1 squared over 4. Okay, so I got standard form. So once you got the standard form, and then we can find the center. So centers is 2n negative 1. So 1, 2, negative 1 right here. And then the a square is a 6, which is a is a plus minus radical 6. And then radical 6 is about 2.4. So you go to the right 2.4. So 1, 2.4 about here. And then go left 2.4. And that's a vertex 1 and vertex 2. And then you go to the 4 units up. So 1, 2, which is 2 units, sorry. B squared is a 4. So B is a plus minus 2. B is plus minus 2. So down to, okay. So you can just connect them together as 4 points. Okay, so this is ellipse. Doesn't look nice. Sorry. Okay. All right. Now the foci. Oh, sorry. So foci, which is c squared equal to a squared minus b squared, which is 6 minus 4 equal to 2. So c is a plus minus rad 2. So plus minus rad 2 is about, rad 2 is 1 point, I think 4. Okay, so 1.4. So in order to find it is 1.4 to go to right. And then 1.4 go to the left. Okay, it's about this place. All right, so now if I say foci, of course this is on the right, so use a center, which is 2, and plus minus rad 2 and negative 1. And for the co-vertices, same thing too. So you use center, which is 2 and but negative 1. And then this time you use the 2 here, plus minus 2. Because you go up to 2 or down 2, right? So which is 2 and 1. And you got 2 and negative 3. Okay? I think that's what I got here, right? Isn't it? This is a point, right? Okay. All right, next page, please. Find the equation in standard form of the ellipse with the vertices at 0 and plus minus 5 and the foci at 0 and plus minus 3. So before I actually find the standard form, I want to know which one has an a square, okay? So I'm just going to do the rough graph. So the vertices on the vertical axis, right? Right here to right here, right? So vertex 1, vertex 2. Foci also here too, C1 and C2, okay? So I know that a squared come with a y, okay? So I'm going to write down as x minus ac squared over b squared and y minus k squared over a squared equal to 1. I like to put it this way. And then the center is always midpoint between the two vertices and two foci. So as you noticed, center is a 0, 0. So h and k is a 0, 0. And then a is actually the distance from the center to the vertex, which is a 5. So a is a 5, which means a squared is 25, okay? And also we have a foci instead of the co-vertices. So which is we have the c here. C is the distance from the center to the foci, which is a 3, which means c squared equal to the 9. So in order to find the b squared, we have to use a formula, which is c squared equal to a squared minus b squared. So 9 is equal to 25 minus b squared. Subtract 25 both sides. Negative 16 equal to negative b squared. b squared equal to 16, and the b is plus minus 4. But we need to just b squared, right? Okay, so I think I need to ready to write down. So x minus 0 squared over b squared 16 plus y minus k squared over a squared to 25 equal to 1. Oh, it's k is 0, sorry. Which is x squared over 16 plus y squared over 25 equal to 1. So that's the formula as you can find. Okay, example 3. Find the equation in standard for the ellipse with the minor axis of the length of 4, vertices at the negative 7 and 1 and 1 and 1. So on the plane, you got negative 7 and 1 and 1 and 1, right? Okay, so those are the vertices. And then which means we have to find the midpoint to get the center, okay? So to get the center, I have to use a midpoint from the vertices, okay? So h is adding the 2x together, divided by 2. K is adding 2y together, and then divided by 2. So center is -1. Those are the h and k. And then also the minor axis is a length of 4, which means minor x is actually the 2b. So which means 2b is a 4, which is b is a 2. So we got b squared, which is a 4. And then the vertices are actually the distance from the center. The A is the distance from the center to the vertex. Okay, so center is right here. So this is actually going to be A. Okay. So the negative 7 to the negative 3, right? Well, okay, so how far is that? 4, isn't it? So I know there's an A is a 4, which means A squared is a 16. I think we're ready to write down the formula, right? So x minus h squared over, this time is a squared. And then y minus k squared over b squared equal to 1. So x minus h is a negative 3. Square of a squared 16. And y minus k is a 1. Square over b squared is a 4. Simplify, x plus 3 squared over 16 plus y minus 1 squared over 4 equal to 1. Okay, so that's ellipse in the formulas. All right. Okay, thank you for listening.